Ford CEO Jim Farley has just shaken the automotive world with a groundbreaking revelation that could redefine the industry's future. At the center of this seismic shift is a revolutionary new engine, one boldly positioned to challenge the dominance of electric vehicles, EVs. The announcement has rippled across both the automotive and energy sectors, signaling that the battle for the future of mobility is far from over. This monumental move underscores Ford's unwavering commitment to innovation and its ambition to remain a formidable force in an increasingly fierce global market. More than just a new powertrain, the development represents a radical rethinking of internal combustion engine ICE potential, redirecting a trajectory that many believed was locked into an all-electric future. Before we dive deeper, make sure to smash that like button and subscribe to stay ahead of the curve on the latest in automotive innovation. Unveiled during a high-profile showcase, the engine is the product of cutting-edge engineering and visionary design. Ford claims it delivers not only exceptional performance, but also addresses pressing environmental concerns. Unlike conventional ICEs, this powertrain is said to be highly efficient, significantly cleaner, and even capable of outperforming some of the most advanced EVs currently on the road. Ford's engineering team appears to have made remarkable strides in resolving the long-standing pain points of emissions and fuel consumption. The result? A combustion engine that challenges the notion that electric is the only path forward. This bold leap forward repositions Ford as a true innovator, one unafraid to question industry orthodoxy and rewrite the future on its own terms. Farley's announcement couldn't have come at a more pivotal moment. As the automotive industry accelerates toward electrification, with automakers pouring billions into EV development, Ford's breakthrough presents a powerful counter-narrative. It suggests that the internal combustion engine is not a relic of the past, but rather a platform still ripe with untapped potential and opportunity. By doing so, Ford is not only preserving an option for traditional car enthusiasts, but also creating a compelling case for consumers who may have been hesitant to embrace electric vehicles due to concerns over charging infrastructure, range anxiety, or battery disposal issues. The unveiling was accompanied by a series of demonstrations that highlighted the engine's remarkable capabilities. The powertrain delivered exceptional torque and acceleration, outpacing comparable EVs in certain tests. This performance advantage positions Ford's technology as a serious competitor in the high-performance segment, where electric vehicles have often been celebrated for their instant torque and rapid acceleration. The new engine also boasts impressive fuel economy, achieved through a combination of advanced materials, innovative combustion techniques, and proprietary software designed to optimize performance in real time. One of the most significant aspects of this engine is its environmental profile. Ford has integrated cutting-edge emission reduction technologies, allowing the powertrain to produce significantly lower levels of pollutants compared to conventional ICEs. This advancement addresses a key criticism of traditional engines, which have long been seen as major contributors to greenhouse gas emissions and urban air pollution. By achieving such breakthroughs, Ford challenges the perception that only electric vehicles can lead the way to a greener future. This development not only provides a sustainable alternative for regions where EV adoption is slower due to infrastructure challenges, but also ensures compliance with increasingly stringent global emission standards. The impact of this announcement extends beyond the automotive industry, influencing various related sectors. The energy industry, for instance, could see a shift in demand patterns as the adoption of Ford's advanced engine technology grows. Unlike EVs, which rely heavily on electricity generated from renewable and non-renewable sources, Ford's engine offers flexibility in fuel usage, potentially paving the way for the wider adoption of cleaner synthetic fuels or biofuels. This adaptability could reduce the strain on existing power grids, which are already facing challenges in regions with rapid EV adoption. The implications for the global supply chain are equally significant. Electric vehicles depend on a complex and often geographically concentrated supply chain for batteries, particularly involving rare earth metals such as lithium, cobalt, and nickel. These resources are not only limited, but also raise environmental and ethical concerns due to the mining practices involved. The internal combustion engine has long been a symbol of human ingenuity, a marvel of engineering that defined the 20th century. It represents the freedom of the open road, the thrill of acceleration, and the mechanical artistry that has captivated generations of drivers. By reinventing the ICE, Ford preserves this cultural legacy while adapting it to the demands of a changing world. This balance of heritage and innovation resonates deeply with automotive enthusiasts and reinforces the emotional connection many people have with their vehicles. The geopolitical ramifications of Ford's engine are equally significant. The global push for EVs has concentrated power in regions that dominate the battery supply chain, such as China, which controls a substantial portion of the world's lithium processing capacity. By reducing dependence on batteries, Ford's innovation could decentralize this power dynamic, offering a counterbalance to the growing influence of battery-producing nations. This shift could lead to greater energy independence for countries that rely on imported batteries and rare earth materials, fostering a more equitable global energy landscape. Ford's announcement also forces policymakers to rethink existing regulatory frameworks. Many governments have implemented aggressive timelines for phasing out internal combustion engines, often under the assumption that EVs are the only viable solution for reducing emissions. Ford's engine challenges this narrative, demonstrating that advanced ICE technology can achieve comparable environmental outcomes. This could lead to more flexible policies that incentivize innovation across a broader spectrum of technologies, rather than favoring a single solution. Such an approach would encourage healthy competition and accelerate progress towards sustainability. The competitive landscape within the automotive industry is likely to shift dramatically as a result of Ford's announcement. Automakers that have fully committed to electrification may find themselves reevaluating their strategies in light of Ford's innovation. Some may choose to reinvest in ICE research, while others may focus on hybrid solutions that combine the best aspects of internal combustion and electric propulsion. The diversity of responses will spur a new era of experimentation and creativity, driving the industry toward greater innovation. Ford's engine also has implications for mobility solutions beyond passenger cars. Commercial vehicles, which are often seen as a challenging segment for electrification due to their heavy payloads and long operating hours, could benefit immensely from this technology. Ford's engine offers a practical alternative for trucks, buses, and other vehicles that require high performance and efficiency under demanding conditions. This advancement could accelerate the adoption of cleaner technologies in sectors that are critical to global commerce and transportation. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Ford CEO Jim Farley's claim about disrupting the EV industry? We want to hear from you. Thank you for watching and see you next time.